Okay, hi everyone, TwoSum. Given an array of integer nums and an integer target, return true if two numbers such that they add up to the target. Okay, again, don't be tough on the writers of these challenges for their English. TwoSum. So we have two things in a tuple, and we're gonna sum them all up together. And if the thing in the second argument is equal to the sum of all of the things inside of that first argument tuple, then we return true. So 3 plus 3 is 6. 3 plus 2 plus 4, 6. Wait a second, am I messing something up there? Help me out. Let's go back. Given an array of integer nums and integer target, return true if the numbers such that they add up the target. Well, 3 plus 2 plus 4 does not equal 6. Did I do something wrong?
2 and 4 equals 6.
Wait, what? Is this wrong? 1 second. Did I just like completely misunderstand it's been a second since I prepared these. Did I like completely misunderstand what this one is? We have to start over, I'm sorry. Wait, what? TwoSum. Huh? All right, did I write something for this? Simple addition of two figures.
That looks correct. Like 2 and 4 is 6, so it should return true.
What is, okay, how about this one? 2 and 7 is 9. So are these just decoys? What are these other values in here? Ignore them?
Yeah, the test cases are just written out so that the answers are at the front of the tuple, but you need to find, like, it's worst case quadratic for all of the pairwise combinations in there, add those and match it to the targets.
Oh, so we're seeing if any combination of adding these things together equals this. So does any combination of 3, 2, and 4 equal 6?
Mm-hmm.
Oh, okay. I'm sorry. I prepared these, like some of these a long time ago. Okay. Very sorry for wasting your time. Let's start over. All right, TwoSum. So this one's a little bit complicated. I'll help you through it. So given an array of integer nums and a second argument, which is the target, we're going to return true if two numbers in the array add up to that target, any two numbers. So here, there's only two numbers, so they have to add together. Does 3 plus 3 equal 6? True. Great. Here, we have to look at all of the possible pairwise combinations of the values inside of the array and see whether or not any of them possibly add up to 6. So 3 plus 2 is 5. Nope. 3 plus 4 is 7. No. But 2 plus 4 is 6. Yes. So any of them do add up to 6. This one returns true. Let's look at this one. There's no combination of values in here that adds up to 15 because 15 is in there. So like anything you add to it would be more. That's a way of looking at that. Same thing here, 2 plus 7 equals 9. But, you know, even though 7 plus 11 doesn't and 11 plus 15 doesn't and all those other things, there's at least one thing in here that equals 9. So we get out true. False, in this case, nothing adds up to 0 except 0. So see how that works? Okay. How would you even begin other than, if I had to start this, I would begin by going into the corner and crying. Where would you start on this? Hopefully not crying. It's okay if you need to though.
So TwoSum is a popular problem. I've heard of it before. I know a general approach to the solution. The question would be how to do it in TypeScript and what helper types I need to implement to achieve it. One type I think I'll definitely need will be subtract, and also just comparing less than.
Okay.
Which I don't really see a way to do this without these types. Maybe with just subtract. So yeah, extends number. I'm just going to start here.
Okay.
Then go over the high-level overview of what I'll be doing in the main TwoSum type. Also definitely need repeat once again. I'll just copy paste that at this point.
Understandable.
So yeah, subtract.
Yep, and for anyone watching, we did repeat in a prior challenge, so that's where we're grabbing it from. Okay.
So yeah, well, for subtract, once we have repeat, we can just do this.
Okay. Infer. Oh, okay. Interesting.
So,
Wow, that's a clever
yeah,
way to solve that. I'll format it for you. Don't worry.
Yeah, rest should be a minus b at this point. But if a is lesser than b, then we're going to get a negative number, which we're not going to consider that case. There's a subtract challenge in the repo, number 7561, which isn't extreme. I don't think it should be, but that also specifies the same. If it's negative, return a never. So yeah, that's what we're going to do. But this is going to be really useful because we have a way now to tell when a is strictly lesser than b. If subtract ab returns never, then we know that a is lesser than b. We'll just wrap that into its own function.
All right. I see where you're going with this.
This is just going to use subtract under the hood. So it's going to be a wrapper. If it's never, then true. If it's not, then false. So yeah, that's. I think
we have to do the is never check. Don't we have to wrap it like? Don't we have to do that?
No, in this case, actually, just.
Oh, because we're using because it's returning a.
Sure, but, it's just returning never. So yeah, that should work.
Oh, okay. All right. Yeah, I got you.
Yeah, okay. Let's try it out later whether your version works as well. I'd be curious to see that. Yeah, TwoSum.
All right. So we got less than, subtract, repeat. All right.
And yeah, repeat probably isn't going to be used directly in TwoSum. But yeah, we have a number and a wait, it's not a number, is it? It's a array. Numbers.
And the final one is a number. Yep.
And yeah, use number. Let me just write this as target, just so it's readable. And what we're going to do is iterate over the numbers and compare it to the rest of iterate over the numbers, then subtract that number from targets, and see if we get a match for target minus current number in the rest of the array that we haven't examined yet. So what we're trying to do is we have cur, and we have some number that may or may not be in the array that equal to targets. Yeah, we're going to just go ahead and search. Yeah, sorry. Search the array, the tuple, for this number. But we don't need to search the entire array every time. We only need to search to the right of whichever current number we're looking at. I'll just write it out, and it's probably going to make more sense.
Okay.
So current.
So is this like you've seen this problem before? I haven't seen this problem before. Is this like you said it's a common computer sciencey like trivia question type thing?
Yeah, it's like FizzBuzz and TwoSum are probably the most popular.
Really? I mean, I certainly know FizzBuzz, but okay. Wonderful.
Yeah, so yeah, that's how I'm aware of the general approach. So current, that's just going to be the first element there. We're going to have a next, which is we're going to pass this next in as the T in the input array in the recursive calls. So I would like to have a shift here, but we can just implement it on the fly because we're awesome. T0 is there at
Yep.
first. And we can have the rest to infer. Yeah. Wait.
Yeah, we need a generic constraint. Yep. Or a conditional.
There it is. Just for completeness.
All right.
That gives us rest.
Oops.
And otherwise, just empty.
There.
Yeah, I think that's...
We made it. Okay, we almost went off screen, but we got it. We got it going. And for you're just shifting. You're just grabbing removing the first value. Okay, cool.
Yep, that's all we're doing. We're just shifting the tuple, and I think we're ready for the final boolean, which that we're going to return at the end. So yeah, the base case is going to be we do a lot of the shift operations and return an empty array finally, and that gets passed into T. So that's the base case here. So if that happens, that means we haven't found a candidate, a matching number that equals target minus cur. So we're going to return false because if we find it, we're going to return somewhere in here, the other branch. So another base case that we can consider is if target
and then are we going to use next here?
Yeah, it's going to be in another branch. Let me refresh my memory on.
So we have T
case.
Okay, the target is okay, these are the parameters passed in. So no matter what, we have to pass in like the first thing in TwoSum. Oh, we're using less than. Oh, we didn't implement less than. Oh, we did right here. I'm sorry. So we're subtracting.
And yeah, we'll be using TwoSum as well. Yeah, let me come back to what might be an edge case or not. After I round out the main like recursive call. So if target minus cur, which is this. So what we're going to do here is we don't need to iterate over the entire next tuple and compare the elements one by one to that left-hand side. We can just do this. And
we can just grab, that's really clever. We can just grab the values of the union and then do a union comparison.
Exactly, yeah. So
wow.
This gives us
that is something.
True.
Yeah.
Here's the recursive.
Wow, we don't need to, it's like doing set comparison. Very fast to do a hash set comparison. Wow.
Yeah, I'm not actually sure how the union comparing works. Is that linear time or constant? Do you know?
Mm-hmm. I don't know. I wish I knew. But this is
you don't have to manually iterate through the tuple at least. Using just next number, you get a union type of all of the elements in next.
I see. So we're starting with the first value. We're adding up every prior value and adding and then concatenating that to a union, checking to see if we found the value that we want, the target anyway. And if we didn't, then we keep going until we hit the end of the list. And otherwise, and then the end of the list would be empty array, in which case we return false.
Yep.
Is that it?
So. But I think I'm missing something here.
Let's look at what the tests. Okay, let's check out the tests. Mm-hmm. So they all just say false. Okay, well that doesn't help, or does it? Yeah, no. Wait, one of them says true. Wait a second. So the one that says true is.
I think we might need to restart the server.
Yeah, let me do that. Restart TypeScript server. Let's see. Okay, so the one that says true is A5. Because it has a 0 in it. I'm just curious, if I put a 0 in here on A4, it would also say true. Okay, so it returns true for 0 and false for everything else.
Wait, is this, there's no guarantee that the input is sorted, right?
I don't think so. I mean, it doesn't say in the challenge, but this input is not sorted. But the other ones would still, I mean, let's try to debug it a little bit. So this is the current value. Where does current get used? It gets used down here. Okay. Okay, and this is the next value, or is it the, it's next is like the array of the next things. Yeah, it's a number array. Okay. And then result extends Boolean. So T extends, should this, instead of T, shouldn't this be next?
No, well, you could formulate it that way, but I think.
Because every time it gets passed in, when we recurse, we're passing in next. Okay, all right, I understand. But okay, yeah, that makes sense. If T extends empty array, then false. Otherwise, subtract target from current. Maybe this should be flipped, target and current?
Nope, that's correct.
Extends next number.
I think what I'm doing wrong is I should be excluding only cur from next, which is, these numbers are unique though, right? Distinct, the input, no, they aren't, 3, 3. Okay, that's.
So subtract returns like a number. It's not a union of numbers. Is that right? No, rest. No, yeah, subtract returns a union. Yeah, it does, because we're inferring. No, this is an array. So wait a second. This is our problem. We need to convert subtract into a union. Subtract will never extend this. Okay, that's why they're all returning false, except for 0. Does that make sense? Because 0 does extend next 0, because 0 is in the list, because it has to be. Okay. So I think our problem is that subtract returns a tuple, but we need to do a tuple to union. And actually,
no, I think I have to return a number or never. Here, I was missing the length thing here, and this probably shouldn't be length either.
Okay, something. Oh, and we need push.
Oh yeah, there it is.
So okay, type. Actually, you know what? I think I have push. Let me just grab it. 1 second. From a previous challenge. Let me see if I can. Here. Push. There we go. Okay, we should have caught that sooner. But anyway, it's all good. So true. So these 3 are failing. The rest are succeeding. 1, 2, 3. So it says true for the 0. Interesting. And 1. Okay, so we got to the true case when I want to kind of like split my screen here. Can I do that? It's a little risky. That's okay. So when it adds up to 1, or when it adds up to 0, 1, or 2, there's nothing here. It says true for these. Is that because it can pass? How could it possibly pass? So like, let's take A5 just for a second. Oops. How could A5 get here? Well, would you like me to I could just show you a couple. So of course, like all of these, I did look up different solutions. Would you like me to just show you a few, and maybe we'll come back to it?
Yeah, sure.
Awesome. Okay, let's do that. We won't wave the flag quite yet to give up, but I have 2. Let's see them. They're very different from the ones from what you just came up with, but here's one of them. So we have a couple helper types. We've talked about this before. I like to use the abacus because I think it's cute. We're not using the value inside of this array, so it can be an abacus array. That's fine. It's just a counter. So we're constructing a tuple from a union. This is an addition. So we're using construct tuple in the addition. So that's how that functions. And then TwoSum union. So let's take a check of it. We're using TwoSum union though. Actually, let's go to the bottom because then we can see like kind of where it's coming from. So TwoSum union, this has those two input values, and we're seeing whether U extends TwoSum union, which is a I guess this is allowing for a union of values in there. I'm not sure how that would actually function in the second argument, but anywho, if it does, then we return true. Otherwise, we return false. Okay, so the meet is happening in this one, TwoSum union. So index is initialized to 0. Accumulator is initialized to 0. So we're saying, does index extend to? So that means like, have we started to get to a point where we should start, or where we should stop rather, and just return the accumulator? If not, if we shouldn't stop, then let's go, right? So we have head, we have tail. Tail extends number array. I bet you any money if we take this out, we'll get an error. And we do, because TwoSum union, it's unknown at this point, because there could be other things inside here, because I don't know why. I've seen this error lots of times in TypeScript, and it doesn't make the most sense in the world to me how this is possible that it could be, that tail could be anything other. Do you have any idea on this?
Nope.
It's just a thing. I don't know. It's like just a fact of life that seems to happen from time to time, that you get these weird things where TypeScript needs you to say extends number array. It said that T is only a number array, so I don't know how it could be anything else. I guess T could be an empty. I mean, I guess maybe this is what it is. T could be that. Maybe that's what it is. I answered my own question. T could be an empty tuple, which is not a number array. So anywho, we are making a union here. That's what these pipes here, this pipe and this pipe down here on 121 and 126. And from there, the first argument we're passing in is tail. So because we're recursing, we're going to lop things off the front, and then we're going to pass them through. So we're passing them in both cases. But here's where it gets different. So we have this union. This makes a little bit of sense, but this one, we're incrementing the index by 1 because we've proceeded one more into the array, and we're incrementing the accumulator by head. Head is the value at the beginning of T. So if the first time iteration, like let's take A12 as an example, head will be 3, and tail will be 2, 0 as a number array, right? As a tuple. So we're kind of going through and grabbing values like that. All right, the next one, okay, before I go on, any feelings or thoughts about this one?
Yeah, clever, I like it.
It is kind of nice. Using all those helpers is always like a pretty good thing. This next one, or last one, I should say, I only grabbed 2, is by Team Chong again. This person makes really good and interesting challenges, challenge solutions. So is sum of, let's just do a high level view, is sum of 2 tuple array, and then we have TwoSum. Okay, so that's our bullet points. Let's look down from the top. So from TwoSum, we have the same initial generic constraints. For the counter this time, it used 1. See, instead of 1, you could do like, a array or something. It doesn't, I don't think it, does it matter? Oh, it does matter in this case. Okay, I stand corrected. This is an array of counters. It's an array of arrays. And some people call that a multi-dimensional array, but that's not what a multi-dimensional array is. But anywho, but it is under the hood, I suppose. 2 tuple array is what counters is initialized to. So let's first take a peek at 2 tuple array. So 2 tuple array takes a number array, great, because that's what T is. And it's going to take off the first and last values like the head and tail. And the first one it's going to put in the front, 2 tuple, and the second, and then it's going to spread out the rest with recursion. So now we get to look at 2 tuple. This is actually a prior challenge that was solved. And I like this person put explanations at the top. So it's going to be like, if you pass in 1, you'll get back an array with just 1 value. If you pass in 2, you'll get back an array with 2 values. Pass in 3, you'll get back an array with 3 values. If you haven't guessed yet, we're going to be using that fact to grab the length, because these are working as counters. And then we have is sum of. Let's see where is sum of is used. So we got 2 tuple array. Counters is we're going to kind of grab the first value off. And again, it's the first counter is like a 1 array. That's kind of like a single counter is that. And we're saying we're getting A and B, like head and tail off of that. And then here's where is sum of comes. So let's take a look. Last helper type. So if U is, it shows up here, if U is 3 and A is 2, then we're going to return, and the rest is 4, 5, we're going to return true. Let's look at the actual code. So we have these counters. Again, that's what a one, I should have made an alias for this in retrospect, like a single counter. And we're seeing if the thing that was passed in as rest extends that, extends infer B and then rest B. So we have like multiple levels of tails at this point. It gets very confusing, but if you stop and stare at it, it should make sense. Then we're gonna spread in those counters together. So we're kind of combining them in one go and checking their length. If that length extends U, which is the number that we passed in that we want to check against, then we return true, because then the sum of those two things is U. That's true. So great. Otherwise, we want to continue recursing. And again, we're only going to hit this case when the length of these two things does not match, meaning we need to keep recursing. Sometimes I worry when I explain these things that it just sounds like word salad gobbledygook. But it's how it is. I don't know how else to say it. These things are kind of complicated. It's we're getting into some really destructively difficult challenges, and this is not easy, this one. But okay, anyway, we can return if you want to any thoughts on that one?
Yeah, it's basically the same approach I'm taking, and yeah, it's very concise. I like it.
Yeah, I like this person's solutions. All right, do you want to take a look at this one again, or what do you think?
Yeah, I found what the issue is.
Oh, okay. So we have push, repeat. Oh, we need repeat as well.
So do you know if never extends like anything, like everything?
Yeah. So in order for never, so like anything that did we have extends never? Yeah. This just doesn't work as far as I understand, because, well, I don't know if I want to get into it. So there was a challenge called is never. And in that challenge, we talked at great length, and I had like charts and I showed like a bunch of different examples of how it actually functions. If you want to check whether something is never, you have to wrap it with these tuple guys. And it says this in the TypeScript docs. It's to break the distributive union thing that happens when you do conditionals. So never is able to be distributed on technically because never is the empty union. Never is like the empty set. So due to that, we get into this situation where if we want to actually check whether something is never and that thing that we're checking against is possibly a union, then it is assignable to the empty set because everything is. So it's like, I guess I said I wouldn't explain it and then I just tried to explain it, but check out the is never challenge and we talk at more length about it. But was that the issue? It doesn't pass.
So yeah, that line isn't the issue.
Oh, okay.
It's line 64. So the subtract target cur can be never, can be a negative number. And never apparently extends that union. So we need another conditional there for the case where subtract resolves to never. So what we need is
okay.
If we had every sum or any all type, we could do this more clearly, like cleanly. But I guess we can just add more nested ternaries.
It's all good. I'll nest them. Don't worry about it.
So I'm gonna do never, check for this first. If it's not, we just want to move on to the next recursive call.
Mm-hmm.
And if not, then we're going to check above. Now we're going to check this now that we know that target is larger than or equal to current. And if we find if extends returns true here, resolves to true, we will have found the match. So now we do true and false branch here. We recurse again, and I think that should pass all test cases. Okay.
Can you give it to me? Okay, actually, better. Let me try to say it, and you tell me where I'm. So, if we're all out of values of t, then return false because there's nothing left and we didn't find what we're looking for. That part I get. If subtracting target from current extends never, meaning what? Oh, we said that. Okay, that's like a special case. So we could have put any value in here, and then it would still work if we did this. Yeah, it does still work. Okay, so. That part confused me, but now it confuses me less. Okay, I got it. Then we're gonna recurse in that case because we have more values to go through. Otherwise, if that same thing that we were talking about before extends next number, yeah, explain this part. 66.
So yeah, this is where we either find or don't find a match for target minus cur. So current plus some number in the rest of the array that we're looking at need to be equal. So that's current plus whatever that number is, sum up to target.
Right, because current is a value of the, okay, and next, okay, yes. I think I understand, because current is just the first value of t, and as we recurse, that's going to be the like target value. Well, target's already used. That'll be like the present value that we're working with, and then from there we can keep. Very clever. Wow. Well, I'm glad that you've seen something like this before. I have to say to anybody watching, this is really tough stuff. So don't feel bad if this is if it feels like how in the world could somebody come up with something like this. It's a very slow process, I think. And using lots of helpers like we saw in these other examples and also the one here is really the only path. I think like breaking the problem up. When you get into something like this, like try to break the problem up into smaller pieces that you can more easily manage. And some of these can probably, like, for example, will it work if we say, yeah, so like we could get rid of current there. Like sometimes it's nice to do refactors after, like, I mean, like technically, here, like, let's do a little experiment just for fun.
Yep, we could just pass it in.
Will it work? No, there's probably some type error or there's some syntax error somewhere. But my point is like, oh, because I had a, wait a second, because I had selected the, okay, now we're just wasting time and having fun, but that's okay. No, it doesn't work. Okay. Anyway, but what I was going to say is that eventually you can get into this situation where you get it to pass. Once you get it to pass, it's good to like take a step back and try to look at how to clean it up or refine it so it's easier to see. Of course, that's subjective, but all right, we did it. You did it. I didn't do anything. Any thoughts on this before we go?
On that last part, like one thing you lose by just passing in T0 instead of cur would be this assertion here, extends number, which if this were a problem where you were passing in new values to cur, this position, that might come in handy and you might want to have this out here explicitly instead of in the recursive call.
Yeah,
but
yeah, totally.
That definitely depends on the problem. For this, you don't need it. This passing in T0 instead of cur should work perfectly well.
For sure. Wow. Okay, I'm impressed. I remain impressed. Okay. Well, anyway, thank you.